This will be recorded and provided after. So if you don't want to be recorded, you can drop and watch the recording after the fact. But we hope you stay because live questions would be great. All right, Shannon, it's all you, man. You did the first half of this.
Yeah, no worries. Yeah, let me do. I guess I'll give you a little bit of a background on kind of where we were going with this. We had a request on the NetOps side, where it was like, hey, we want to do a whole bunch of blocking and create whitelist or for the customers to be able to come in through some. I think they had some firewalls or something. I don't remember the exact area we were working in, but and it came down to the point of like, how do you keep these updated and how can we automate those? And by the way, how do you whitelist all of India, or how do you whitelist all of a country, and who's holding that data? And, so that kind of drove us down this path of like, all right, there's some places that we've seen that do this. And one of those just happened to be, there's a company called MaxMind that does this. And I'd had experience with MaxMind in my personal home lab dealing with OpenSense or pfSense, and using that as an GeoIP blocker. And I was like, hey, I've dealt with MaxMind before. Let's take a look at that and see if there's any opportunity around being able to leverage those same lists that I'm using for GeoIP with blocking home to do for GeoIP authorizing here at work. So went out, looked at MaxMind, and of course, they have several different options of that we have for India that we're aware of, in terms of they'll slice and dice by country, and then they'll superset and subset some of those. And in our case, we were more interested in the by country, basically looking at India really is what we were after. Well, the question is how do we take that list, because they're updating that list, looks like at minimum twice a week, and keep our IPs up to date so that if anyone runs out and says, I want to run this Terraform module to update our whitelist on the firewalls or the gateways or whatever, then I'm like, how do we put that out there? How do we keep it up to date in a repo that someone could consume? And that's kind of what drove this part of what I'm discussing and what we're talking about today. I'm going to do a little bit of a screen share just so you guys can kind of see a little bit of the code and we can kind of step through it. Does anyone have any questions so far before we talk about the actual code?
Yeah.
Yeah, go ahead.
Okay. This is Sean. Sorry, guys. We were using geo blocking at one point, but AWS does not support geo blocking whenever you're doing a network load balancer or an application load balancer, like certain situations where you have to have a static IP in front. Would this solution work for us? Yeah, platform's AWS, by the way, guys.
I can't personally answer that. I don't know if someone else would know.
It depends on the number of IPs that the NLB would let you target. So if you're using a security group, I think you can have 60 CIDRs or something. And the US zone has 110,000 CIDRs, so it's not even close.
Yeah, our issue is that the NACL rules is what's really holding us back, because you can only block it at, so many. I think it's 40 or something like that, and then you're done.
Yeah, I think the solution most people do is just put it behind CloudFront because that supports country targeting, but it wouldn't use the cool widget that we built. You can just say like US, India, permit, everything else deny, or whatever you need.
And I'm perfectly fine with that. Unfortunately, they won't allow us to do it because we're using network load balancers. It doesn't allow us to put CloudFront in front of it.
Interesting. I haven't had to put CloudFront in front of an NLB, but let's investigate that and get back to you, Sean, because that sounds cool.
Okay, perfect.
Any other questions before we dive into the repo and the code? Cool. All right, so I'm going to talk about the actual workflow here, and then we'll get into the actual PowerShell that's doing a lot of the work, and then we'll see what the output looks like. We had a standard issue, GitHub action going on here. And so basically you set this guy to run every Wednesday at 4 a.m. because I think they update on Tuesday. So this made sure that I had plenty of time, for their update to get out there. We have a license key from MaxMind, and then we've set a couple of variables set up and some Slack in here. So that's all fairly standard issue. But we basically check out the repos, so that all the repos in the pipeline. We've got access to that PowerShell here in just a moment. And then what we'll do is we actually download and process those CSVs with the PS1. And then we turn right back around and we update the repo and recommit it back as the newest and latest update into main right here inside the code. So we're in a position to update the repo, and I'll show you a little bit of why I did it that way. And then right behind that, we use Slack, to say, hey, just letting everyone know we've been updated, and we push it out to a channel. So if you take a look before we get into the actual PowerShell side of this, you'll notice the last commit was updated repo with current GeoIP data, and then can't see the rest here, but it does show, in this case, you can see like the actual CSV and the zip file and everything. The point being that if we ever needed to see what date and time the last time this was done without having to look at necessarily at the commit times and everything, it's nice being able just to look at the commit. So that's where part of that workflow comes in. I'm one of those people that, like, I hate to dig down into the code just to see something like, oh, was it updated on what day? So that was kind of in game there. So if we get back over to the PowerShell side here, we'll talk about that. And so the way that MaxMind releases this data is as a zip file. So I found out that if you look at MaxMind, they have a specific setup for, like, I want it by country CSV, or I want it by certain blocks or whatever. So the GeoIP 2 country CSV is what we were after, because they basically, inside of there is a text file for, well, there's multiple files, but there's basically 2 files, and you have to basically, one of them lists all of the country and the other one lists the actual IPs for those countries. And so you have to understand that there's a country ID that you have to get out of one file to find all of the data in the actual IP list, and you have to be able to look that up with the country ID. So basically the zip file has 2 files when it comes down, and so we're saying, hey, download the newest, and then what I want you to do is just pull it down and grab that zip file, and then we're going to turn around, we're going to unzip it, and we unzip everything, and then we actually start to work through the data. And there's, I'm not going to deep dive into every little step here. I won't bore everyone, but the point is that, suffice to say, we say, look, if I'm looking, I've got 2 files, unzip everything, and now let's start creating some data. And it turns out that the country ID will have the full country name, like India. It will also have an abbreviation like IN for India. And so what I wanted to do is I wanted to set something up where we could have that abbreviation as part of the name of the file, but I would also have the full name as India, and then I would have every IP address for India in that file. So what I'm doing is I'm taking all the data out of those CSVs, and you can see the CSV work going on right here. And I'm like, hey, I want you to grab this country out of the first file that they have all the countries in, give me the ID number, now go over to the CSVs for the IPs, and I want you to give me every IP based on that country ID. And what we've done when I did this was I extracted every country out of there. I was like, rather than just create this for one, none, or some, let's just do it all, and let's just create and make them consumable. That way the data is always there for any country, and all we have to do is make some changes, to our other Terraform to consume whatever country we want. So this is doing all the extraction, and what it does, it puts it out into a folder right here. And you can see this is AD, Andorra, and so forth and so on. So since we were working on India, I'll give you that example. And if we look here, this is every IP according to MaxMind IP's database that belongs in India or to India in some form or fashion. And they come in insiders and so forth and so on. You can see how the data looks here. So this puts us in a position to, let Terraform consume and chunk this list depending on what country I want or countries. And the way that this is set up at this point, in the way that it's all been done and it's been working a treat, is I just have this set to update and create these lists every Wednesday at like 4 in the morning. And all it does is it goes out to MaxMind, downloads it, processes their data, creates all these files. And then at that point, we're in a position to say, just pick your poison as to which country you want to IP block or allow. And then that's about it, I think, on that. So I can answer more questions around the code if someone wants to. I just don't want to deep dive and, et cetera. But that's the general overview of how we're updating this list every week on a cadence.
Hey, Shannon, it's Alex. I noticed you were running this on a Windows runner. Did you try this on Ubuntu?
I have not. At the time, I was just working with straight up PowerShell there, and so I mean, I could certainly go to Ubuntu and run PWSH there. I just haven't even gone back to revisit it yet.
Okay, cool. Yeah,
cool.
just, and I think some of you know the reason I'm asking is because the Windows runners are a little bit heavier in terms of resources, mainly because of their larger disk footprint. Kind of pushes them towards larger runners.
Yeah, I want to say, yeah, and the nice part about all this, I haven't looked at this in a little bit. In under 1 minute, we're extrapolating all that data, which is really fast. That's really cool. Side note to that, like I said, I won't bore you guys too much with the code, but I will show you one thing that I did find of interest in this particular project. And I gave credit where credit was due on this. Someone had an article out there, and you can see the HTTP from 2015. And it was kind of interesting. Instead of dealing with a whole bunch of hash tables and CSVs and shifting stuff around, they actually leveraged some like data tables. And so it was kind of almost like an ADO, like setting up like an ADO in-memory database. And I will definitively say, once I got the idea of what this guy was talking about, I was like, oh, I see where this is going. And off we went. And it took it down from like 10 minutes down to somewhere around about, you're seeing under a minute. So that was kind of an interesting use of data tables from a PowerShell perspective. All right, Kyler, I'll turn you loose.
All right. And so Shannon and I were talking about this really cool thing that he built. Like we have all the IPs for all the countries in the world sorted by country. That's so cool and so useful, and I need it, but I need it in Terraform. And so like, how do I read that data? Do we need to shim it in somewhere and then use a data call to get it? So what I opted to do is create an output for Shannon's repo, for Shannon's MaxMind PowerShell repo. And that's pretty weird at first, right? Because like, this isn't a Terraform repo. There's no Terraform resources. There's no Terraform data calls. There's no Terraform at all, except for the output. But Terraform has some cool functions that permit it to read files, and you can generate outputs from that stuff. So I initially just created some really simple iteratives that would call like the US and India and stuff like that and output their lists. So they look like this. This is Terraform console where you can just like look at your data and check it out. So here's the list of country IPs filtered for the US. But I just was curious if I could write an iterative that would read all of them. There are 250 countries represented in this data set, all with just some number of IPs, ranging from a couple for Andorra to like 110,000 for the United States. And I was able to get it working eventually. Super cool. So we read all the file set, which is show me the list of files in this location in the module path, IP list by country with no filter, and then iterate over them. Find the country shortcode, which is just at the beginning, like split the string by the underscore, and you can see like AD, AE, AF. Use that to store it as a country code. Then find the country name, which is just the entire thing. Remove the TXT, replace it with nothing. And then compact it by splitting it by new lines to read it as a list, because it is a list, but it's not a list in the programmatic sense. It's not wrapped in square brackets. It doesn't have commas. It's just a straight up list that a human would understand, but not Terraform. So we read it as a list using split and compact, and it turns it into a list. And then we post-process it and just say for country, read the list, and then set the key, so convert it to a map, the country shortcode to the list. So let's look at that for a second. So if I just say, show me the country map, that just printed like 600,000 lines of text. But you can see it builds this map like that. So it's filtered by AD, which is really easy to process. So I can say, look at the country map. and just give me like, let's look at Zimbabwe because it's down here at the bottom. Just give me ZW. So that just prints Zimbabwe. And then it has attributes. One of those is country IPs. And I can say, just give me the country IPs. And I think length will give me the count. There are apparently 149 IPs assigned on the public internet to Zimbabwe, which is really cool. All of that works really, really well. And it just creates that whole output map. Like that's a 600,000 line output map, but it generates it in about 2 seconds because it's all local computation. There are no calls to any provider to build all this stuff. And then I put some examples here. Like if you want to use it, you can call this module and you don't send it anything because it doesn't take any input. It's just processing local data in this repo and then sending you stuff back. And then you can reference like the United States. You could use a star here and it would give you all of them, all the country IPs for every country in the world. And that's not useful, but you could get it if you want. All of these are accessible. And then some of these do chunking, and I'll go over that better in a second. And this is really tiny, but this is where we're actually using it. So this is over on the Chia project. We have a firewall that's in front of an application gateway that's in front of some servers. And that architecture works great for us, except we want the firewall. What was that? Oh, sorry, I must have heard someone. And that works great for us, except that we want the firewall, the thing that's external most, to only permit the US and India. That's the only countries where we should be receiving valid traffic from. But firewalls don't support like the US and India. They support permit, deny based on IPs, based on CIDRs. So we need it to read those lists. So what we do is actually call that module. So we call Shannon's PowerShell module, and the only Terraform code it can find is the outputs. So it reads those as outputs. And then we want to build some IP groups because in Azure, you don't directly pipe stuff to resources. Generally, you build IP groups and then use those to build your policies. It's very hierarchical, works really well. And so we want to chunk them because the most CIDRs that can exist in an IP group is 5,000. And remember, the United States is like 111,000 CIDRs. So it's a lot of IP groups. And you would think like, oh, we have to update our code every time it crosses that threshold. How are we going to do notifications? No, we can just do chunking. So what this does is create a chunked list from this enormous 111,000 CIDR list that we're pulling from here. And just chunk it by 5,000s. So make a whole bunch of lists and just put them in a list. So it's a list of lists of CIDRs. So we're grabbing all of them from there, we're chunking it together, and then we're building IP groups, and we're doing a count over the length. We could probably do a for each, but count is useful because it's a number, a numerical iterative, and we can say build the number that we need because there's like 24 chunks, I think, and call it this, and we can use the count index to help number them and use the CIDRs based on the count index. And what it looks like when it actually runs is here. So up for India, there's 1, 2, 3. Allow India 01, 02, 03. And if I click into one, you can see where this is being used. And over here is IP addresses. There are 5,000 IPs. Now, managing these by hand would be just atrocious. Like that would just be a terrible job to have to just go through these IPs and do them by hand. And I don't mean to throw shade at anyone, but I think this is how the Chia team was doing this previously. I think their SOC did regular imports, and I imagine you would have to delete all the IPs and overwrite them or have some kind of atomic logic to what has been added, what has been removed, because these CIDRs occasionally move from different countries. So Terraform does that. Like that's its whole job, is managing atomic stuff based on like a declarative config that you want to see. So we use Terraform exactly how it's meant, and it works. It works really, really well. The way that we Terraform works, but it takes a really long time. So whenever we run this, it has to individually check those IPs and there's 111,000 for the United States. I think there's 11,000 for India, so it does 125,000 API calls. That takes a really long time. Like, it takes about 40 minutes, even with a fast runner, because like just network calls take time, and making 125,000 calls takes a lot of time. So we decided to put this in an entirely separate repo. This doesn't build firewalls, this builds IP groups. And we aren't going to manually update it. We're going to have it run automatically. And so this is something that Jake built. Is Jake on the call so I can call him out? I'm going to call him out regardless. No, I don't see him on the call. Well, Jake on the Chia team built this really cool thing to, I think we're using batch. We basically just put this behind a cron. So in the exact same way that Shannon's thing once a week goes out and automatically gets all the IPs and puts them into the repository, once a week, we also automatically run, maybe it's under batch. There we go. There's our cron. So we run just right after Shannon's does. And this runs daily because why not? It takes 45 minutes and no one has to touch it. And it automatically approves itself and deploys to our environments, including production, fully automated. So we like go and read Shannon's hard work stuff from that Terraform output from the PowerShell and update the IP groups, which automatically updates all of the policies that are linked to those IP groups. So within maybe an hour of Shannon getting the new download of new CIDRs, all of our policies across all of our firewalls, across all of our environments are updated and ready to go with no human interaction whatsoever. Like it's totally automated. Shannon and I have our feet kicked up. I think that's all. We could go into it more if anyone wants to see it, but that's it. And we'll provide links to all this stuff if you want to go poke at the code too. Man, I talked for a long time. Does anyone have any questions about anything? I either did a really good job or a really bad job when there's no questions.
You guys did a great job. I mean, my observation is that you're doing essentially what services like CloudFront are doing to implement, I would assume, geo-blocking.
I think so.
We're just having to do it manually because we're putting it on our own firewall.
Yeah. Yes. Do we have any tests for if somehow Shannon's job fails that it doesn't start the secondary job?
No, they're separate actions that use separate crons, and there's no kind of circuit breaker dependency that if A fails, B should also pause. So just run, and if Shannon's code is wrong, it just wouldn't succeed, and it wouldn't break our IP groups. But if Shannon's code is wrong, so I keep calling it Shannon's code, if MaxMind gives us like an incomplete data set, then we would propagate that incomplete data set. So yeah, for sure, that is a risk.
Is there any way that we could put something in there to validate? Like if the number of IPs dramatically changed by, like over, 15%.
Totally. Like standard deviation.
Yeah.
Yeah, to that point, Ross, I'm wondering if and Shannon, maybe are we getting like MD5s or SHA sums for the files that we can then check and see, hey, did we get the whole file? So I know we've had to deal with that when we've been transferring data sets and things like that.
Let me check.
Because that would be a good way to validate, to Ross's point.
Yeah.
Yeah, we could certainly see if they host that. I don't know if they show that or not in MaxMind. I'd have to log in and find out.
Okay.
Also, if Shannon's code, for lack of a better term, generated a partial list, would it not fail in a good way? In other words, not provide an updated list at all? Like if it was partially done and it caught some sort of weird error and the whole thing borked, would that be a state where, hey, it only gives you iterated through, 30% of what it needs to do. So it's going to give us a list that's 30% complete, or would it give us nothing at all? I think we want to fail in a way where we don't accidentally put a partial in there, right?
Right.
I think we fail by default. There's nothing that says like continue on error. I think the curl would fail, which would exit the action, and it wouldn't continue to do the commits. And that's what we key off of for the secondary job, the Terraform job. It reads the files. So if the files aren't ever updated, we don't propagate bad stuff.
Yeah, the pipeline would fail as soon as it hits that error, right?
And it should detect that. Like that's curl's whole job, is make sure like all the files are properly copied over. It would be cool to check hashes.
So it turns out that they do have a SHA-256 as part of their download. I'm looking at it in the background. So, we can certainly come back and upload, fix that in the PowerShell to say, if this match that, then go to work, effectively.
Yeah, I'm just trying to think of what could go wrong, right? I'm just trying to put in some circuit breakers, as you said, to make sure that we don't, move forward.
Yeah, I don't mind. I hadn't investigated their SHA-256, but it's sitting right there. So, that wouldn't take much to get involved in. That'd be pretty easy.
Okay.
I'll take that as a takeaway and see if I can get that implemented.
Thanks, Shannon.
You bet. No, thanks for the info. It's always good to get other teams' ideas, because my head's down just going, right code, it's working, let's go, Sometimes I don't, sometimes we don't see the other angle. So no, it's good.
Links are in the chat. Oh yeah, go ahead, Alex.
Yeah, I was just also just wondering aloud, like, what happens if you lose a worker? Like if you're in the middle of doing this work, kind of again, back to Ross's scenario where there's incomplete data provided somewhere. We have safeguards in place, like if the job fails, and because I haven't looked at the generator enough to see, when is all the data copied out? One of the new text files made available in the repo. Is that like once the job finishes, then we get all the files out there, or are they being incrementally updated? I guess I can work with you on that separately, Shannon, because I'm kind of curious. And now that you guys are showing me this, I'm wanting to dig in.
Yeah, by all means. I'd say, if we can get all three of us in a room together, it'd be pretty interesting to have that conversation. That's for sure. I'd like to know.
Yeah, cool.
And this is intended to be shared code and not just our child. So if you see something cool you want to add, you can do it. Feel free to talk to us too if you want to, but also this code is shared for a reason. I think that's it. We can hang out for more questions if anyone has anything. And like Gordon said, if anyone has any ideas of stuff they want to share, we're going to try and treat this like a conference. We're just going to have a monthly Veradigm internal conference, and you can give a 20 or 40-minute talk. You can do PowerPoints, but it doesn't have to be polished like that. Shannon and I just wanted to show you some cool code and talk about it, and yours could be like that too.
Yeah, and thank you both for taking the time to go through with it, and also for building it, because I know that was an initial ask from me for Shannon. We did have that limitation on the firewall end where we would have had to manually go out there and manage lists, and that would have been a nightmare, or we just don't have GeoIP at all. So this was a perfect solution. So thank you all.
Yep. And thanks for the challenge. And that was a lot of fun. I enjoyed it. It was pure entertainment on this side.
Me too.
Throw in a real quick comment. This was really great. Thank you for presenting this. I've been using this stuff for at least 2 months now, I think. We similarly have a weekly cron schedule that runs and updates the IP groups for us and everything. But another shout out to you, Kyler. The other flip side of this is that data resource that you added or got added for Terraform to actually read those IP groups back, because that was a nightmare. Building them, it was easy enough, but then pulling that list of IP groups back was a nightmare. So that is sort of the flip side of this, which is also needed, which is fantastic. And we have that implemented and working great now as well.
For context for everyone, there wasn't an Azure RM data set for multiple IP groups. There was just one for single IP groups. So we could build all these IP groups, but like I want to consume them in a different Terraform layer. And we were doing remote state calls, which works fine, but it's kludgy and the dependencies are kind of annoying. So I just kind of ignored my job for a week, genuinely, and wrote a plural data source for IP groups. So you could give it like a partial name and it would find all the names that looked like that, like just use simple regex and give you all their IDs and names, which is cool. And I'll probably do more of those in the future. And if that's something folks want to hear about, like adding stuff to the Terraform providers, I think that's really cool. It was hard because it's Go. It's not similar to Python and Bash that I'm more used to, but it was fun. It was sure cool.
I need to learn Go.
It's so cool and it's so hard when you're not used to it. But Copilot wrote like half of it. Copilot did a great job.
It seems like a lot of times in my home lab, things are done in Go, and I'm like, man, if I could just I don't even know what this thing's doing. I'll just leave it alone. Yeah, need to do that.
I'll share a link to that if anyone wants to poke at it. But really, if y'all want to hear about that in a month at a Tech Talk, like if no one else has any better ideas, please someone else have other ideas. But if you don't, we could talk about that.
Sounds great. Awesome.
Cool.
Well, it sounds like we don't have too many other questions. Again, thank you all for joining. We're hoping to get a good cadence with this, so definitely come back with us next month. And Shannon and Kyler, thank you both again.
Yeah, no problem. Thank you guys for just taking the time to check out something we did. I appreciate that.
Thanks, Al.
Thanks, everyone.
Take care.